Hello, today we're going to do 18.6 practical graphs. It's on page 174 to 175. It's carrying on from what we've been doing before, so it shouldn't be too confusing hopefully. Hopefully this video is going to be quite short. So I'm going to start off with drawing straight line graphs. Just a bit of a recap. We've done this a few times. So you can do it using the method with a table, or you can do it using the method with M and C, the intercept and the gradient. I'm going to be doing it this way just to make sure we can all get a bit faster. If you don't like it that way, you can still use the table, but for this topic it'll probably help. So that's just a recap. You can skip that if you're confident. Then I'm going to do some examples and talk about what's involved in the topic, and then the questions are set at the end. So like I said, you can skip this one if you're confident. You should be definitely watching these two. Okay, straight into it. Drawing straight line graphs. So we can do it, like we said, with the table of values and plotting each point, or we can try and get quicker. We should identify the gradient. It's +4. So that's where we cross this y-axis. So we look here, +4. It's there. Then we look at the next part, it's the gradient, -3. That means for every one step we go across, we go down 3. 1, 2, 3. That's it. That's the gradient of -3. 1 across, down 3. And again, across 1, down 3. 1, 2, 3. So there's our points. We could keep going to get more, but there's no need. We could check them by putting them into the equation. That's another thing you could do. But they'll all work out. Then just join them up. So like I said, when I draw these axes, I don't have squared paper or anything, so mine are a little bit off. But when you're doing it in the book, it should be perfect. On your paper, it should be perfect. Okay, so I missed that point there. That wasn't very good. I'll do it one more. So it's just about identifying that gradient, the intercept, and get it done. Let's say we've got a gradient of 1/2 and intercept -3. So like I said, identify the intercept, go to that point, -3. And then this gradient of 1/2 means you go across 1, up 1/2. Now, so that's actually a point, but if people don't like half points, we can just go across 1 again and up another 1/2. Oh, it's right there, same point as the other one. And do it again, across 1, up 1/2, across 1, up 1/2. Cross 1 up 1/2, cross 1 up 1/2. And we're getting all our points. Get your ruler, join them up. And mine's not very good. Again, with your squared paper, it should be much better. And there we go. Easy, fast, quick ways to draw straight lines. Just get the intercept, that's where you start, then sort of count up the gradient. Right, so this chapter, it's about straight lines, but in real life. We're going to give you problems, and then you have to put them on a graph, and then probably answer some questions. We're going to use all the skills we've learned already, and I'll talk about that in a moment. But we're going to think about how it works in real life. So for this one, let's read the question. There are 12 boats in a harbour, so let's underline that, it's important. One boat leaves every 20 minutes. Oh, that's important. Draw a graph to show that. So we could either make an equation for this, which some of you might like to do, or we could just try and draw it on the graph. I'm going to make the equation and then we can see how it fits into the graph first. So if we're starting off with 12 boats, that's going to be our intercept. So we're going to have something x plus something. If we're starting off with 12, that's where it's going to intercept the y-axis. So we can just put that there. And then one boat leaves every 20 minutes. So you can either work out a gradient for 1 minute, but that's going to be a bit harder, or we can do 1 hour. So if 1 leaves every 20 minutes, that's 3 leaves every hour. So the gradient is -3. Okay, so I'm not going to explain that much more. Hopefully you sort of follow along with what I did there. If you can't work that out, it's fine, because you'll just be plotting it on the graph. Hopefully you can see what I've done. If we were going to do every minute, we would divide one, it would be a 20th. So we would divide 1 by 20. Okay, so if you didn't understand that, just ignore it for now. Now's the time to draw the graph. So we've got to think about this in real life. Are we going to get a negative number of boats? Well, you'd think if the time goes on long enough, you're going to get a negative amount of boats. But it doesn't make sense. So there's no point drawing something that doesn't make sense in real life for this chapter, because this is all about real life. So we're not going to have a negative amount of boats. So on our y-axis, that's this one, we don't need to have the negative part down here. Okay? And what about for time? Are we going to have a negative amount of time? Are we going to go back into the past? I guess we could sort of think about and make our line extend into the past, but it's not asking us to do that. So we're simply sticking to the part it's asking us about. So we're working with the positive part of each axis. So I'm just going to draw it, like this. Okay, so now we've just got the positive parts of each axis. And then I'm going to go up in 2s on the y-axis to make sure everything fits. So 2, 4, 6, 8, 10, 12. So remember, you can change how much you go up by on axes. You don't have to always go up by 1. And then on here, so here's the number of boats. I forgot to label the axis. And here's going to be time. So you could go up in 20 minutes if you wanted. You could go 20, 40, 1 hour, so 60. Or you could just go up in hours. I'll carry on like this. I'll just put 1 hour here. So then 80, 100, 120, 2 hours. It's a bit small, but hopefully you can kind of see what I'm doing. 140. 160, 180, 3 hours. Okay, and then if we wanted, we could extend that on. Now, to the actual plotting. So the 12 boats in a harbour, that's what we start at. So we're starting at 12. Let me change the colour to make it a bit more clear. There's 12 boats, so we start at 12. When no time has passed, there's 12 boats in the harbour. So it's the same as the intercept is 12. One boat leaves every 20 minutes, so we can do that. After 20 minutes, we've gone down to 11 boats. After 40, it's 10. After an hour, we're on 9 boats. And so on. We can see, after we've got a few points, we can join them up and just make the whole graph. So, I've extended the line past. I shouldn't extend it past on this one because it doesn't make sense to have negative boats like I was talking about. But going back on this side over here, it's okay because we can sort of predict what was happening in the past. Okay, and that's it. So you should be able to see we've got our intercept of 12, and the gradient of -3 is because every hour we're going down 3, like this. Okay, so once you've got it drawn, they might ask you some questions. For example, they'll probably ask how long until there are, until there are no boats. And what we would do, we'd read our file graph, no boats is here. Okay, so we should extend it a bit further. So 200, 220. So 240 minutes, which is the same as 4 hours. So just once you've drawn it, it's just reading it off the graph. Another question they might ask is, they might say, there are I don't know, maybe 7 boats. How long has it been? So we go to 7 and we read down. It's been 100 minutes. Okay, so once you've drawn the graph, it should be, hopefully, a bit more straightforward to answer the questions. Here's another one. I just wanted to show you this one because the axes will change because we're using quite a big number. Okay, so there are 350 leaves on a tree. Each week the tree grows 50 more. Show this on a graph. So again, we don't really need the negative. We're not going to go back into the past for the time. And we're actually getting more and more leaves. So we're not going to ever go into the negative for the amount of leaves. Also, it doesn't make sense to have negative amount of leaves on tree. So again, we're sticking to the positives. And I think for most of these, you'll be doing positives. I'll have a look through in a moment. But usually in sort of practical situations in real life, there are some we get negatives, but I think for this chapter, no, it's going to be mostly positives. So again, we're going to have time on the bottom, and we're going to have leaves this time on the side. I'm going to make the equation just so we can, for the people who are interested. So we're going to have y equals something x plus something. Well, we're starting with 350 leaves. So that's our intercept. And we're going up by 50 each week. So that's it. Because we're going to do time in weeks to make it easy for ourselves. So let's do 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then I'll go up in 50s, I think, for this axis, just to make it easy. So 50, 100, 150, 200, 250, 300, 350, 400, 450, and so on. So again, we can extend that further if we want to. Now let's just draw it quickly. We're starting at 350 leaves, so let's go to 350. Each week we're going up 50 more, so here, 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 and so on. Drawing the points. And so my graph, I don't have much room on this page, so I've not got to see much of the graph, but hopefully you get the idea. Then it'll ask you some questions. At what time does the tree have 500 leaves? So we go to 500, go down after 3 weeks. Then it might say, well, you get the idea. It's going to ask you questions from there. Hopefully that all made sense. I'll be on Zoom later, so we can talk to me about this if you get confused. These are the questions. It's page 174 to 175. All questions, please. And the brains are a bit more like this last question I did with the big numbers. So it should still be straightforward, but if you're getting confused, you don't have to do them. That's everything. So good luck.